and welcome to Junction. My name is Simon Timms.
And I'm Eric Fleming.
And today's episode, we're going to take a look at how you can wrap functions. So if we were using something like ASP.NET MVC, we would have a pipeline that we could hook into in order to do stuff on every function call. So if there was something you wanted to do, maybe check an authentication or something like that on every single function call, you could write some middleware and intercept that. So as it stands right now, there is no way of doing that in functions. So if you want to do something in every function, you've got to go and do something in every function, which is a little bit of a pain, and we kind of don't want to do that. This is a possibility you're going to forget one of them, or that you're going to mess it up, or there's going to be something. Anyway, it's a lot of duplicated functionality across your functions. So fortunately, there is a way around that, and the way around it that we're going to try is aspect-oriented programming. For people who are unfamiliar with aspect-oriented programming, and specifically we're going to use a library or a tool called PostSharp, which is it's called Aspect Weaver. So the idea here is that normally your code is divided up into kind of like silos. So you would say like, this is the functionality of this class, and we have the power to do inheritance inside of C#. So we can say that like a circle implements or extends a shape object. And we don't like to do that too much because it's very strong coupling, but we do it from time to time, and it is useful to share functionality. But if you had a piece of functionality that existed across a bunch of different things, and like the implementation was shared, but it didn't really make sense for these things to have a common ancestor, and I'm going to try and reach on my shape objects. So let's say we're building a drawing program, and we have a shape object like a circle, and we want to be able to apply a label to it. But we also have things that aren't shapes like clip art that we want to be able to apply a label to. So those things might not have a common ancestor, but we want to be able to apply a label to all of them. So we could say that although they don't have a common ancestor, they share a common aspect in that they are things that have labels on them. So an aspect allows us to handle these cross-cutting concerns, that we can apply this piece of code across a bunch of different places. And other languages have different approaches for dealing with this. So if you were writing C++, you might use multiple inheritance to do the same thing. If you were writing JavaScript, you might use mix-ins to kind of like monkey patch these functions into various other places. But for C#, we have aspects. And Java is the same. It uses aspects for this stuff too. So PostSharp, anyway, is a tool that you can download and hook into Visual Studio. I'm using the free version, which is sufficient for doing what we're doing here. If you had a large project with a lot of functions, then you might want to go and spend some money and buy the actual version proper. The limits that are put on PostSharp, I think, are like size of project limits, so I can get away with doing this on, I don't know, well, maybe like 10 functions. But if I had more than 10 functions, then I would need to go and spend a little bit of money. But it's super cool and worthwhile to do. So I have created here a brand new project, creatively called Aspects, and I've added to it an HTTP function, which is just our normal HTTP function. So I'm going to comment this line out here. Don't look at this line. It doesn't exist yet. So we'll just go and run this. And I've decided that we have a cross-cutting concern, which is authorization. So there's some built-in authorization stuff in functions, but I'm super custom. I want to use my own custom authentication stuff. So if I go over here, and this is Postman, I'll just go and run a request, and after a little bit of compilation, it'll come back with hello Simon. So this is not super creative, but we want to apply some checking to this. So I want to make sure that anybody who calls this function passes in a key in the header. So to do that, I'm going to go and create this aspect here. So a bit too much white space in this class. Jot some of that down. But basically, what I have here is a piece of code that wraps the function call that this thing is assigned to. So anytime that my function over here is invoked, it's actually going to intercept it with this code right here. So we're going to start off with, I'm going to go and I'm going to pull from the arguments that are passed into the function. So the arguments that are coming in over here, which are the request, the name, and a traceroute log. I'm going to go and look for anything that is an HTTP request message, which is the request. And I'm going to go and grab that here. I should probably check and make sure this isn't null. We'll just assume that it's not null for now. And I'm going to take these request headers and I'm going to get the key out of it. So this is the actual HTTP key, or the actual like HTTP headers, and there's something called key here. And I'm going to check and make sure that the value of that is equal to let me in. So obviously, if we were doing proper authorization, we have a better check than this. We go off to a database or a key store or something like that and double check that what had been passed in was correct. So if that works fine, then I'm going to go ahead and I'm going to invoke the function. So this is just like the normal workflow that would happen, and it will fall through into this code over here. If it doesn't work, then I'm going to hijack the response that comes back. So I'm going to args.return value, which is what's coming in for this method interceptor arguments here. And I'm going to create a new HTTP response message, and I'm just going to give it a 403 of forbidden. And then I'm going to come over here and annotate this method over here with parameter check. So this is an annotation that says anytime that you go to call this method, actually call this method. I should quit Slack here. Do that. So in theory, this should just work. So let's give this a try here. So I'm going to go and I'm going to start this up again. And this aspect weaving stuff is transparent. The way it actually works behind the scenes is we'll generate the files, and then PostSharp will go in and rewrite the IL to insert all of these checks and all these interceptors into it.
All right, that's really nice.
Yeah, so we're up and running here again. So everything should be just the same. So we'll do the same thing that we tried last time here. I'm not passing in the key yet. So we'll send this message, and you can see that I get a 403 forbidden back. But if I go and I pass in this key, it's going to go hit that interceptor, and there we go. Now it's working just fine.
Nice.
Yeah, so I think that there is some talk about having kind of a pipeline for functions in a future version, but if you're using functions right now and you need to do something on every function call, then this is a great way of doing it. I'm using an annotation here to call this, but you can actually tell PostSharp, you can give it some instructions and say like, hey, bind everything that matches this pattern. So if I was doing a bunch of functions in this project, I would probably tell PostSharp like, hey, bind anything that is a function, or that is in a class that ends with function or something like that. By some convention I would use to tell PostSharp which ones to bind. And then that way that if people on the team added new functions, we could be comfortable that those functions were going to get the interceptors applied to them and would kind of work transparently in line with everything else. So we're kind of setting ourselves up to fall into the pit of success.
Very awesome.
Yeah. So aspects are pretty cool. You can do all sorts of stuff with them. Logging is always a really popular one. So if we wanted to log every request that came into our system, we could go ahead and put that over in here. Because we have access to all the arguments, we can even use the same trace writer that came out. Let's go and try that out and see how it works, just so we can run one through here. So it could be really excitable here. We'll create a whole new function here. Whole new aspect rather. Okay, so let's call it logging. Put that here, and then I'm just going to go and steal this whole method, but then I'm going to trim it down. So we actually want the arguments of type trace writer. I'm not sure where trace writer is defined. There we go. Okay, and then this thing, we're going to always call invoke on this one, so we don't worry too much about it. But here we can go logger.trace function, and then on the other side, looks like I need to pass something more to that. What do I pass into this thing? Log.info should go like pass in. What's this?
You have logger.trace. Do you want logger.info?
Yes, that's probably what I want. All right, there we go. Good catch. We'll do the same thing here. Did call function. And we'll go and apply this aspect over here as well.
So you can apply multiple aspects?
Yeah. I'm not sure exactly the order in which they get applied. Probably the same order in which this is called, so we probably want logging to apply first. Let's see. Coding on the fly. Let's see if this works.
Yeah, it's actually interesting. So if you had the two aspects there and they both call invoke, would it invoke the method twice?
No, I think it would like call down to the child one. So like
Okay.
it'll wrap the invocation and then it'll wrap that again.
Gotcha.
But let's find out and see here. This could just blow up terribly in our faces. Okay, well, it looked like it returned okay. What did we get in our output here? Did call function, about to call function. There we go. So if you wanted to add logging universally across this, you can do the same thing. And it's just that easy.
That is awesome.
Yeah, I'm super keen on this stuff. Okay, I think that's probably everything that I wanted to cover. So we'll see everybody on the next episode of Function Junction.
Bye, everyone.
Bye.